Hey, and welcome back. This is video 8 in our series on electricity for junior cycle science. In this video, we're going to look at using Ohm's law, which is the formula that we learned last day that links current, potential difference, and resistance. So we learned about that formula and where it comes from and how we kind of built our way up to creating the formula. Before we begin today, a couple of questions to make sure that you actually do understand where that formula came from. And if you haven't already watched that video, then this video is definitely going to be harder to understand. So you should really watch them in order. Go and watch that now. And as usual, turn off if you've got your mobile phone on you, turn it off or put it away where it can't distract you, and close any open tabs. Here's some questions then. And as usual, if you aren't going to do the questions, then you're not going to learn anything by doing this video. So you really need to make sure you give all the questions your absolute best shot. Okay, so there should be all revision questions, and you should be doing them from memory without looking back at your notes from previous topics. So what I want you to do is I want you to pause the video and answer these questions now, please. Okay, so what happens? You should only be hearing my voice now if you have done the questions. What happens to the current when the potential difference is increased? It increases. So if the potential difference is increased, the current increases. How do we describe this relationship? Well, when you have a relationship like this, where when you do something to one, it does the same to the other. So increase in one increases the other, or decrease in one decreases the other. We call this relationship proportional. So this is a proportional relationship. Again, we described that in the last video. That should not be brand new. So well done if you said that. What happens to the current when the resistance is increased? It would decrease. So resistance increase, you put more bulbs in the circuit, then that slows down the current. So it reduces the current, decreases it. How do we describe this relationship? So this is a type of relationship between two things where if we increase one, it decreases the other. So it has the effect of, it has like the opposite effect on the other. We call this an inversely proportional relationship. Inversely proportional. Ohm's law states the relationship, or shows the relationship between current, potential difference, and resistance. What is the formula that best describes Ohm's law? Well, that would be current equals voltage, or potential difference, divided by resistance. Okay, so voltage equals current equals potential difference divided by resistance. So here are your answers written down. If you need to make any corrections, you should physically correct them with a red pen, or you should make changes to your answers now. Now I'm going to have to really that's technically not very correct there. This should actually say potential difference. So some people use voltage in place of potential difference, and you can see why, because the units for potential difference are volts. So some people call it voltage, but potential difference is correct, is technically the more correct term. Potential difference divided by resistance. All right, so again, it was important that we recap and make sure you're really comfortable with that formula before we go ahead and start trying to use it. So today we're going to learn how to use this formula. Before we do, I want to introduce you to a method which we can use to solve basically using any equation in junior science, and it applies to a lot of maths questions as well, or maths equations, and it works like this. So if you've seen this before, if you've been in my class and you're comfortable with this, or you've seen me do a video on this before, then you can go ahead and skip this little bit. The method is called the DESCU method, DESCU. And I get all my students to write these words down the side of the page when they're doing a problem. So D stands for data. So on this line, we would start by including our data from the question. E stands for equation. So on this line, or in this space, we would write the equation we need to use to solve the problem. So what equation links up the variables in the data? S stands for substitute. So this means you put numbers into the equation instead of the words. C stands for calculate. So you're actually going to use your calculator in this step. And U stands for units. What units am I answering? So this is a method for using equations in science. And it works for any formula or any equation. Okay, so science. So what I want you to do, if you haven't seen this before, if you've seen me use this before and you're pretty comfortable with it, you don't need to take this down. But if you have, if this is brand new for you, then I would suggest you pause the video and take that down now, please. All right, so you should only be playing if you're either comfortable with this or you have or you have taken it down. We're going to see how we use it now. All right, let's look at some problems. All right, so here we have our first problem. And as you can see, this is going to be one that I do. So I'm going to do this one, and then we're going to slowly transfer responsibility to you. All right, so let's read our question. Calculate the current flowing when a 45 ohm resistor has 20 volts of potential difference across it. My first line is data. What data do I have in the question? Well, here are the key parts of the question. It says calculate the current. So calculate the current. I need to find the current. So I obviously do not know the current. Okay, so that's going to be a question mark. So here in my data line, current, or current has the symbol I, is equal to question mark. I don't know. Okay, so calculate the current when a 45 ohm resistor. Okay, so I know the resistance or equals 45. So here I probably should have said I equals question mark. Okay, so now I know in my data line, resistance or equals 45 ohms. Okay, and what else do I know from my question? Well, a 45 resistor has 20 volts of potential difference across it. There's another piece of information. I know the potential difference, or V, equals 20 volts. So potential difference equals 20 volts. And this is the symbol V. Okay, so that's how I would take my question and work out the data from it. Okay, let's look at the equation. What is the equation? Well, this is Ohm's law. It's current equals potential difference divided by resistance, or or just using the symbols, it's going to make the pen a little bit finer. I for current equals V for potential difference divided by R for resistance. So from now on, I'm going to use this shortened version, but know that I'm just using the symbols instead of the longer words. The third line is substitute. We can substitute when we know the number for a word. So for instance, current, I do not know. I do not know any current here. So that's going to stay a word because I can't put in a number. So it's going to stay as current. Or I'm not going to actually write current. I'm going to write I for short, just to start shorthanding things. I equals. Well, here, I already know that my potential difference is 20 volts. I'm going to take that and I'm going to plug it in instead of potential difference. So I'm going to put 20 here, divided by, I know my resistance is 45 ohms. So I'm going to take my resistance and put that in 45 instead of the word resistance. So that gives me 20 divided by 45. I'm going to need my calculator here. So we'll take out my calculator, and you guys are going to need your calculator now for the rest of the class. And we do 20, I do calculate 20 divided by 45. And that gives me, on the next line where it says calculate, I'm going to get I equals 0.44 recurring. So 0.44 dot for recurring. The last line is units. I equals 0.44. Well, this is current. So the units for current are amps. So AMPS. And that would be my final answer. That is how I use the DESQ method to solve an equation, or to solve an equation in science. Right, we're going to do this one together. Okay, so we're going to do it in steps. Actually, do you know what? You can pause the video and take that one down as a full example. So do that now. Okay, so now we're going to do one together. All right, the first thing we're going to do is we're going to make sure that you get the first bit right. D stands for data. So you should have D here. All right, so D for data. What is the data in the equation? So pause the video, write down the data. Okay, so hopefully you were able to do this line by yourself. Let's check it. What does it say? It says calculate the current again. So again, we have I equals question mark. That's what we're trying to find. We don't know that one. When there is a 90 ohm resistor. Okay, so I know R equals 90 ohms. And that has a potential difference of 15 volts of potential difference. So that tells me V equals 15 volts. So I'm going to put that into the line. I know that I is unknown. It's a question mark. R equals 90 ohms. And I know that V equals 15 volts. Great. What is the equation? Write that down now. Okay, so E, write the equation, pause the video. Okay, so this is what you should have. I equals V over R. That's what you should have. Well done. The next line is S for substitute. So we're going to substitute in numbers where we have them instead of words. Well, I don't have a number for I, so I'm going to leave it as I equals. Again, you should pause the video, should only be playing if you have put in the numbers now. Okay, so I know that V15 goes on top, and I know that 90 goes on the bottom for R. So we put the words in, or the numbers in instead of the words. We've got 15 divided by 90. And I get my calculator out. For the next line is calculate. So I do 15 divided by 90. So on the next line, C, that gives me I equals 0.166 recurring. So what that tells me then is U is I equals 0.166, and the units are amps because this is current. Okay, so well done. If you managed to do the steps when I asked you to pause, you're now ready to take full charge of this and try some questions by yourself. So here they are. I want you to pause the video and find the answers to these now, please. All right, so they're very samey. I'm hoping you've figured out by now that they're all pretty much the exact same as that we're all trying to find. Now, it might be word is slightly different, but look, we're trying to find the current. Find the current, calculate the current. So our current is our unknown in all of these. Okay, so here are the answers. Check your answers and make corrections now. If you got them wrong, you've done something wrong. You need to go back and watch my example again. If you got them right, you should tick them. Do not leave them wrong. If you leave it wrong and just keep going, then you have a problem that you haven't fixed. You really need to go and find out what you did wrong. Okay, so go back and watch my video or part of the video again. All right, let's take a look now at a second couple, a few more examples. Okay. Here is another type of question. Now we can still use the DESQ method, but this time it says, what is the potential difference? So this time the unknown is a different unknown. This time V is the question mark. Potential difference is unknown. We know though that we're creating 14 amps of current. So we know that I is 14 amps. And we know that we have a 12 ohm resistor. So R equals 12 ohms. So on my D line, I have I equals 14 amps. I have V is a question mark, and I have R, which is 12 ohms. On the next line, my equation is I equals V over R. I'm now going to substitute. So I'm going to put in 12 instead of or, and I'm going to put in 14 instead of I, substitute. So I'm going to get 14 equals V over 12. Now, this is where it gets a little bit more complicated. And the reason for that is when you want to find V, you need V by itself. You can't have V divided by 12. We just want to find V. Okay, so V at the moment is being divided by 12. So that's V over 12. To get a full V, what we need to do is multiply V over 12 by 12. But I can't do that to just one side. So I say I multiply both sides by 12. So when I multiply V over 12 by 12, that just gives me V. So anything when you're dividing it by 12, if I take a pizza and divide it by 12, that would give me 12 little slices. If I multiply the little slice by 12, I can get back the full pizza. So when you want to get a whole number, you multiply it by whatever number you're dividing that thing by. So if you've got a quarter, 1 over 4, to get a whole again, would multiply the quarter by 4. And that would give you back 1. It's like a quarter of an orange. If you have only 1/4 of an orange and you want the full orange, you would have to multiply it, get 4 quarters. So multiply the quarter by 4 would give you back the whole orange. It's the same thing here. This is a V divided by 12. We just want a full V, so we've got to multiply it by 12. But we're not allowed to just do that on one side because this here is an equal sign. That means both sides are equal. So if both sides are equal and you're changing one side, you must also change the other side. So when we do that, that gives us now the equation of 12 times 14, which is from the sum over here, equals V. Now we can find V, 12 multiplied by 14. So what I'm going to do now is I am going to take my calculator and do 12 by 14, and that will give me V equals 168. Okay, so when I did 12 by 14, I got 168 units for that. V equals 168 volts, because this is voltage or potential difference, which is measured in volts. Okay, we do one now. So again, I want you to do this. I want you to pause the video, and in the D line here, I want you to write down what the data is that we know. Pause the video and do it now. Okay, this is what you should have. We want to find the potential difference. Okay. We want to find, we want to find the potential difference. So we don't know what V is. V equals question mark. We have a 25 amps of current. So we know that I equals 14 amps. And we also know that we've got a 300 ohm resistor. So R equals 300 ohms. So in this line up, we should have I equals 14 amps. We should have V equals question mark, and we should have R equals to 300 ohms. Next line, what is my equation? Write it down, pause the video, write it down without looking back. Okay, you should have I equals V over R. Good. Next line, substitute. So let's put in the numbers that we know into the equation. So we know that I, current, is 14. That 14 is equal to V, we don't know, so we'll leave it as V. And V at the moment is being divided by 300. So that's dividing V into 300 little pieces. To get the full V, I've got to multiply by 300, but I can't just do it to the right-hand side because this is an equal sign. So I must also multiply the 14 by 300. So when I do that, they can cancel out and just give me one V. That gives me the new equation of 300 times 14 is equal to V. So now to calculate, I get my calculator up and I'm going to get V equals, and I do on my calculator, 300 times 14 equals 4,200. And my units, it's potential difference, so it's 4,200 volts. Okay, so you can take this down as a second example if you like. I don't know if I let you take down the first one. There are the two sums done. Okay, if you need, you can pause the video and make notes of those. And you're ready to do some more practice. So again, you should be ready to go. Here are 6 questions. Okay, now the first 3 are just like the ones we just did, but be careful with number 4. Number 4 changes it up. Be careful, really look at what they're asking you to calculate. Okay, so that's what you have, really check your question. Right, pause the video and do these questions now. Okay. All right, guys, just to note that in the first question, they were looking for you to calculate the potential difference. So you should have been finding V. In the second one, it says what potential difference. So you should be finding V. And in number 3, it says calculate the potential difference. So you should be finding V. In number 4, the difference was what is the current? You should have been finding I again, like the first questions we did. So just if you didn't realize that for number 4, pause the video and go back and take another look at it. Okay, right, here are your answers. So you should either be ticking them that they're right. The first 3 should be in volts. Number 4 should be in amps because you were finding current. And then you're describing the relationships between current and potential difference and current and resistance. And we should be using the word proportional or inversely proportional. Now, at this stage, if you're not getting these right, then you really need to take the time and go back and watch me do the examples again. Do not keep going because they are getting harder. The first ones are the easiest way, but when you need to rearrange the formula like we're doing here, it gets harder. So you really need to master this now. Okay, last examples. Okay, now here we go. Again, we're going to start off with I do. Okay, so teacher does. So find the resistance. This time we need to find or. Or is the question mark. Don't know or. Okay, so find or when a component which allows 25 amps of current. So the current I equals 25 amps to flow when 100 volts. Okay, well, volts, that's potential difference. So that's going to be V equal to 100. So on my data line, I'm going to write that down. I'm going to say I equals 25 amps. I'm going to say V equals 100, and that should be V, volts. And or is the unknown, question mark. We don't know that one. The equation is the same as always. I equals V over or. That's Ohm's law. Substitute is the next line. So I'm going to put in the numbers instead of the words, the numbers instead of the symbols. So I know that I is 25. So I'll put in 25 for I is equal to, I know that V is 100 and I don't know or. Okay. So this time I'm trying to find or, and at the moment, or is in the denominator of a fraction. So at the moment, 100 is being divided by or on the right-hand side of this equation. 100 is being divided by or. Now, if I want to stop 100 from being divided by or and just get 100, then I'm going to multiply 100 over or by or. That's going to get rid of the or in the denominator here. But because this is an equal sign, I have to do the same on the other side. So I have to do or by 25 as well as or by 100 over or. So bear with me. I know this is definitely the hardest one, so stay with me. That's going to give me or times 25 equals to 100. Now I'm not finished yet. I've got another step because I still don't have or by itself yet. At the moment, or is multiplied by 25. I just want to know what or is. So at the moment, to get rid of the 25, I need to divide it by 25. That's going to give me or times 1, which is what I want. Now, because I've divided the left-hand side by 25, I must also divide the right-hand side by 25. Because this is an equal sign, I must do the same to both sides. That's now given me a sum. I now have or equals 100 divided by 25. So because this is a 1 here, it's OR by 1, which is just 1. Really, I could write OR by 1 here, but that's just the same as OR because anything by itself, anything times 1 is just the same. So if it's OR by 1, that's just OR. So we don't really write that OR by 1, we just write OR. Now, again, if you need to, now is the time to rewind just that little bit and watch what I've done on this line, because that's probably the hardest thing you're going to do in this video. So if you need to, take time over this line. This is the hardest bit, most complicated bit. But once you get it, you should be able to do it forever then and be able to do it on any formula. Okay, so on the next line now, I've got to calculate. So I've got a sum now, OR equals 100 divided by 25. I put that into my calculator and I'm going to get OR is equal to 4. So 100 divided by 25 is 4. And what are my units? OR is equal to 4. Well, it's resistance, so the units are ohms. Right, we are going to do one together now. Okay, so first thing I want you to do is pause the video and pick out the data. Pick out the data line. Okay, so you should only watch the video if you filled out the data line. First question here, the question says find the resistance. So again, OR is equal to question mark. Don't know OR. Find the resistance of a component which allows 16 amps of current. So my current is 16 amps. I equal to 16 amps. When to flow when 84 volts of potential difference is put across it. So I know that I've got 84 volts of potential difference. So V equals 84 volts. So on my D line, data, it should say I equal to 16 amps. I have V, which is equal to 84 volts. And I have OR, which is equal to question mark. Now, it's really important that you keep using this DESQ method until you really are comfortable with using the formula in every way that we need to. So all the different ways of using the formula here, like we're showing you, you need to be really comfortable before you stop using DESQ. So every sum you do today, you should really be using DESQ. I know it takes time, but it'll teach you how to do it properly and really master it. Once you really have the hang of it, then you can drop the DESQ. But I wouldn't advise you to do that today at all. You really need to get comfortable with using it first before you think about dropping it. What's the equation? Pause the video and write it down. Okay, so you should be playing. If you wrote the equation down, it's I equals V over OR. Again, you're going to write that so many times today that hopefully you'll know that forever. S stands for substitute. So put the numbers in when you know where you know them. So we know that 16 amps is the current I. That's going to give me 16 here. 16 equals V is 84. As you see here, 84 is the V. Put that in here instead of V. We get 84 divided by OR. So at the moment, I don't want that 84 to be divided by OR. I just want it to be 84. So if I multiply 84 divided by OR, then that cancels those out. But because of the equal sign, I must also multiply the left-hand side by OR. So that gives me this equation. OR times 16 equals to 84. Now, that's still not what I'm after though, because at the moment I've got OR by 16 and I just want to know what 1 OR is. So to fix this, I'm going to divide 16 by itself. That's going to turn it into a 1. Now I also have to divide the right-hand side by 16. Now I've got a sum, OR equals 84 divided by 16. Again, really do take the time here to watch what I've done a couple of times if you need to. C, go ahead and calculate it now. Pause the video and do that. Okay, so what you should have done is 84 divided by 16. 84 divided by 16, and that gives you OR equal to 5.25. So well done if that's what you got. Great. We're not finished yet because we need a unit. This is resistance. So resistance is 5.25 ohms. Excellent. Right. You're ready to go out on your own now and do some more practice. Okay, so this is for the final way of rearranging that equation. And we've also got some mixing up in here. Okay, So be careful about number 6, 7, and 8 because they are a different pattern. So if you look at number 1, it says to find the resistance. If you look at number 2, it says to find the resistance. As you can see, there's a pattern. What resistance? Calculate the resistance. A resistor has a potential difference. What is its resistance in ohms? So there's a question. What is its resistance? That's what we're trying to find. So I'm going to rub this one out here. And then the last 3, though, it does not say find the resistance or what is the resistance. So be careful with those ones. Okay, so you should only be watching the video if you've done questions 1 to 8. If you have not done them, pause the video, make sure you do them. Okay, answers are coming up. Now, it's really important if you just literally write down a list of my answers, then this has been a complete waste of time. And I do not want this to be a complete waste of your time. I want you to learn how to do this and how to use this formula because it's really important. So I want you now to correct your answers, but you should have workings. I'm only showing you the answers. You should have the full workings. Okay. All right, here are the answers. So as you see, the first 1, 2, 3, 4, and 5 are all ohms. So this was from, this was finding resistance, obviously. Find or, that means its answers are in ohms. The next 2, you had to find V, and that's why the answers are in volts. And the last one, you had to find I, and that's why the answers are in amps. Okay, so if you got them all right, then really well done. Okay, that was a big challenge there, a good long set of questions at the end. But you've used that equation so much now and in so many different ways that you really should have a really strong mastery of it. And if this was to come up in your exam, I would be confident that you would do really well if you have done all these questions and got them right. If you haven't, if you've struggled, that's what the videos are good for. You can go back and watch me do the examples again. Oftentimes, it just takes one more look at what I've done for you to fix the smallest little mistake that you're making that's holding you back. Okay. All right, that is it. I hope that you got on good with those questions, and I will see you in the next video.